We'll go on to a new topic, context-free languages. It is known as CFL. Just like you have regular languages, you even have context-free languages. Now, context-free languages are the languages which are generated by a context-free grammar. As we all know, context-free grammar is type 2 grammar and accepted by a push-down automaton. Now, if you look into all the previous examples, like, imagine you have a language which follows something like a raised to n, b raised to n. You very well know that you need memory, which means you should be doing a stack, which means you should be following push-down automata. You can even generate grammar for this. And this particular language where you do all that, you call it to be a context-free language. Imagine you have a language like this, a raised to n, b raised to n. The same logic. You need memory, you need a stack. It can be accepted only by a push-down automata. You can generate only context-free grammar. It is a context-free language. Imagine you think about palindromes. Again, you need a stack because you need to remember the first word, then only you can get the transpose of that word. Okay, so the same logic again applies. Now, all these languages, they come under the category called context-free languages. Now, according to Chomsky's hierarchy, all regular languages come under the category called context-free languages, but all context-free languages, they are not regular. Hope you remember this. This is Chomsky's hierarchy, Chomsky's family of languages. We did see an elongated version of this together with the grammar, automata, and all that. Now, very importantly, you need to learn properties of context-free languages. Now, properties of context-free languages, they come under two heads: closure properties and non-closure properties. They are very interesting, in fact. Now, in closure properties, you have three kind of properties: union, concatenation, and clean stuff. Now, what do you mean by closure properties is, you say that context-free languages are closed under union, concatenation, and your clean stuff or your clean closure. Why? In union, if L1 and L2 are context-free languages, you even say that L1 union L2 is context-free. Similarly, if L1 and L2 are context-free, you even say that the concatenation L1 dot L2 or L1 followed by L2, that is also a context-free language. Clean closure, if you say a language is context-free, even the closure of it, the clean closure, that is also context-free. So, when you mean by closure properties, it means that if two or one language, they are context-free, their union, concatenation, and their clean closure, they are also context-free. The next set of properties, non-closure properties. Non-closure properties. Non-closure properties means they are not closed. Earlier, we were talking about closed. Now we're talking about not closed. Now, in non-closure, there are three: intersection, intersection with regular language, and complement. Closure also we have three. Actually, closure you have more than three, maybe like the homomorphism, inverse, and all that. But those are not very important. Only the three things which we saw are very important. Non-closure, we do have three. Intersection, if L1, L2 are context-free, L1 intersection L2 need not be context-free. It could be a version, but it is not necessarily. Could not be or could be. It is not necessarily a context-free. Now, if L1 is a regular language and L2 is a context-free language, L1 intersection L2 is a context-free language. Okay. L1 intersection L2 does not fall under regular languages, but it will fall under the category called context-free languages. Complement. If L1 is a context-free language, the complement of that need not be context. This is what you mean by non-closure, need not be. Okay, so you have two main set of properties, closure properties and non-closure properties. Closure, you have union, concatenation, clean. And then non-closure, you have intersection with regular languages, and you have complement.